Oh yeah, ladies and gentlemen, welcome. And I say welcome, welcome, welcome to Section 6. Now we've already talked a little bit about Section 6 in class. What's the point of the music? There is none. I just have a background of a baseball and a bat. So there you go. Anyways, here is the essential question for this part of the video. What we're going to be talking about is this. How do we use this thing right here called the principle of reduced triangle to solve right triangle problems? Now, we've already talked in class about the Pythagorean triples, and you know how awesome they are. You can do questions like that. If you know something is, 5, 12, the hypotenuse is 13, like that. You know something is 40 and 41, you know the one leg is 9, like that. It's an awesome, awesome tool. This, however, the principle of reduced triangle, will help you if you're not exactly sure how to do certain side lengths or what it comes out to be. It's going to make your life a little easier. So I'm going to have you do this. Into your notes, let's do this. Write this example. We're going to find the length of the third side of this triangle right here. And what's given to you is one leg is 6. The other leg is, weird, 5/2, so it's a fraction. And we're trying to find the hypotenuse. And here's what I'm going to do for you in this short little video. I'm going to do it two ways. I'm going to show you how to do this two different ways. One, I'm going to call it the change up. Here's why. Because we'll get the right answer. It will just take us a longer time to get to it. But it will absolutely work. So I don't want you to think that this isn't a bad way. It's awesome. It'll just take a little longer. And then I'm going to show you a second way called the fastball. Why? Because it's going to be using this thing called the principle of reduced triangle to get the answer much, much quicker, and in my opinion, even easier, that you don't even need to use a calculator. Really, I mean, you can do it like that. So it's pretty cool. So let's rock and roll. First things first, let's do the change up, and let's see how the change up works to do this particular question. So let me pull over my, this is going to be interesting. I've never done this before, but here we go. What I've just pulled over for you guys is a snapshot, kind of, this is going to be cool, of my iPad. So let me show you how this works. So what I've just done, I've taken the triangle, you can see. I put the leg in here, just straight up Pythagorean theorem. 5/2 squared, that's one of the legs, plus the other leg squared equals the hypotenuse squared. That is my goal. So here we go. I'm going to take the 6 squared. That's pretty simple. That's going to give me 36. X squared is going to be x squared. That's a piece of cake. So what about this 5/2 squared? What about this thing? Well, I must distribute, really, the 2 to that exponent and distribute the 2 to that exponent. So I square the 5 and I square the 2. And that gives me a whopping 25/4. So now here's the problem. Well, it's not a problem. It's just something we have to take care of. Now I have 25/4. I have to add to 36. Ew. Well, the only way that I can add things if I have a fraction is I have to have common denominators. Wow. So that means I have to find a common denominator with these guys. So that means I have to find something over here, the 36, where it is the same thing equivalent, but I have to put it, if you will, in an equivalent fraction of 4 as a denominator. So I'm going to do that over here in this section here. So I have to take 36, and I have to rewrite it as something over 4. Wow, well, how am I going to do that? Well, I can multiply, actually, it's 36/1. So I can multiply this by 4 and this one by 4. So that means 36 times 4 is 144. Wow. So there's my equivalent fraction. So 144, so I got 25/4 plus 144/4 equals x squared. Ooh, I like it. I like it a lot. Okay, so now when I add these fractions, hey, we're getting there. It's the change up, but whatever, it's coming. Here we go. So now when I add fractions, since I have common denominators, I keep the denominator exactly the same. Remember back from elementary school. But I add the numerators. So that gives me 169 divided by x squared. Here we go. So now what do? Well, in order for me to get rid of the x squared, in order for me to get rid of this, I have to take, oh, that's right, the square root of both sides. So I take the square root of this and the square root of this. Whoa. So that means, lovely, the square and the square root cancel each other out. Over here to the left, I had the square root of 169 over 4. Well, remember the rule is this. I can take this, I'll put it over here. You can rewrite it as the square root of 169 over the square root of 4. Oh, that's cool, because I can actually do the square root of 169. That gives me 13. And I can actually do the square root of 4. That gives me 2. So, what is my answer? My answer is this. Woohoo! Right there. That, ladies and gentlemen, is my answer. 13 over 2 is the x value that we got right here. So that is, let me move this out of the way if I can. Lovely. So that right there, 13 over 2, is the answer for the hypotenuse. Using, I'll put this back over, this method where I just simply put it into the Pythagorean theorem. And like I said, it will always work, except it is the change-up method. So, let me move this page over here like this, and let me show you how we can still use the Pythagorean theorem. Whoops, that's actually wrong. Let me correct that. That's a squared. There we go. So a squared plus b squared equals c squared. We can still use the Pythagorean theorem, but we're going to use this thing called the principle of reduced triangle to do it. So here's how that works. Into your notes, this is the fastball. The principle of reduced triangle. I'd write this down because this is rather important. There's 3 steps to it. Principle of reduced triangle. Step 1 is to do this. You need to multiply or divide all 3 sides, not 2 of them, not 1, all 3 sides by the same number to obtain a similar but simpler triangle. So what does that mean? What am I multiplying by? What am I dividing by? Well, it completely depends on the question. And you're going to see as we do a whole bunch of examples in class. But let's get back to the example that we just did. Let me pull this over here. Okay, so what happens is this. Well, according to what I just said, we're going to have to multiply by something to make this a smaller yet more manageable, more manageable triangle. So what I multiply by, guys, I multiply by 2. Why 2? Because that would clear this fraction. So let's do it. I'll multiply this side right here by 2. I'll multiply, that's hard to see, sorry. Here we go. I multiply this side over here by 2. I'll multiply this side here by 2. And I'll multiply this side here by 2. I'm going to hold off on this a second, though, because you'll see why. If I multiply this right here by 2, 2 times 6, that gives me 12. That's pretty simple. So now that's my side length there. If I multiply this 5 halves by 2, the 2's cancel out. So I'm left with a 5. Now I'm going to stop there. Why would you stop there? Because, check this out. I have 5 as one leg. I have 12 as the other leg. Ba-bam! What does that sound like to you? And if you don't know, you need to study. That's a 5, 12, bam, 13 triangle. I don't know why I keep saying bam. It's kind of funny. So it fits into a 5, 12, 13 triangle. So what does that tell me, Mr. Motter? Who cares? Well, here's what it tells you. Check this out. That means then that this 13 would be what this guy right there is supposed to be. And right now, according to this box that I have up here, the hypotenuse is represented as 2x, or just 2 times x. So it creates this little equation where the hypotenuse that is 2x, as a representation right now, is supposed to be 13. Well, okay, so we're still not to our answer. Oh, yeah, we are. If I just divide by 2 and simply solve it for x, which was my original question anyways, to solve it for x, that means I have x is 13 over 2. And that, my friends, is the final answer. That's it. Go back to this one. Remember all the work that we had to do? All of this stuff here, we had to go down through this. We got 13 over 2. That was the change-up. This one, whoa. This one was the fastball, because we were able to just kind of use the principle of reduced triangle and get these numbers down to a smaller, simpler numbers that we can kind of deal with. Now, I got ahead of myself. Let's go back to the steps, because step number 1 I did. Here is actually step number 2. Step number 2, I do this all the time. If I was in class normally, I'd teach the same thing. You got to solve for the missing side. I did that already. I solved for the missing side by doing this 13. It's 5, 12, 13. It's a triple. Sometimes, guys, it won't go into a Pythagorean triple, but it will make smaller, easier, more manageable numbers for you that when you plug it into the Pythagorean theorem, it will still work. That's pretty cool. And then step 3, this is the most crucial step. That's why it's starred 4 times. You have to convert back to the original problem. If you don't convert back to the original problem, of course you don't get the right answer. And that little baseball smiley face dude says the third step is a crucial one, as I just told you. So we have to make sure we convert back. What's that mean? Well, when I got the third side to be 13, that's not the final answer. Since I multiplied everything by 13, I convert back by dividing by, since I multiplied everything by 2, I then convert back by dividing by 2, and that's 13 over 2. So that's pretty cool. I love it. So the principal reduced triangle, we'll do a bunch more examples in class. Got a couple sample problems that you look at, but I love it. It's cool. It's going to save you a ton of time. You'll see. Later. Peace.